Let's take a look at this example. This time we're supposed to add two complex numbers, but one of them is expressed in polar form, another one is expressed in rectangular form. Anytime you want to add that kind of numbers, I mean polar and rectangular, you're supposed to convert one of them to polar or other one to rectangular. So in order to make this problem simple, I'm going to convert polar form to rectangular. Okay? So in order to find the real part, you're supposed to remember this formula already, you have to multiply the magnitude by cosine of the angle. My magnitude is equal to 12. Cosine of angle 35 degrees. This is equal 9.83. If you want to find the imaginary part of this complex number, you're supposed to multiply r by sine theta, which is equal to 12 times sine 35 degrees, and this is equal 6.88. So I can say that my 12 and angle 35 degrees complex number in rectangular form looks like this: x plus jy equals 9.83 plus j 6.88. So I can rewrite this problem as 9.83 plus j 6.88 plus 4 plus j 3. Please notice that right now I can perform the addition because I have identical forms. I mean rectangular form and rectangular form. You can add complex numbers when two forms are identical. So because I have invisible positive sign at the front of these parentheses and I have positive sign at the front of these parentheses, I can simply remove the parentheses and combine the like terms. So I have real number and this is real number, that's why I'm going to write them next to each other. So I have 9.83 plus 4, and if it comes to the imaginary numbers, I have plus j 6.88 plus j 3. 9.83 plus 4 is equal 13.83 plus j 9.88. And this is the solution to my problem.